Hello, you're welcome. All right, so now projectile, right? That's what we're gonna be looking at in this tutorial. Okay, so already, okay, when we treated motion under gravity, I defined projectile as a motion of an object under gravity, okay, that follows a parabolic path from the point of projection to the point it hits the ground. This kind of parabola, okay. For example, when a projectile is when a javelin is being thrown to the air, right? It goes up, then returns back, right? So at the end of the day, you discover one thing about a projectile, okay. The motion is neither vertical nor horizontal, okay. Neither it's not horizontal when we are as we actually considered when we treated linear motion horizontally, right? It's not vertical as we considered when we treated free fall or upward, okay, vertical movement of an object. But you discover that the velocity of the object of a projectile, the object that is undergoing projectile motion, is inclined at an angle, right? So, and this angle is angle of what is known as the angle of projection. So someone throwing the projectile, okay, is throwing it at an angle so that it moves in an angular velocity upward, right? So initial velocity of even the movement of the projectile is at an angle. So the motion of a projectile, if I should redraw this in a graph, all right, if I should redraw this in a graph, right? Let's say this is the vertical. Let's say this is the vertical component of velocity when you consider velocity in the vertical axis, and this is the horizontal component, right? Then the motion of a projectile is neither vertical nor horizontal, but rather second at an angle. So it has these two components. Vectors make us understand that anytime, alright, any vector quantity is neither vertical nor horizontal in a plane dimension to in a plane this is a two-dimension representation, vertical and horizontal, right? So anytime a vector is not neither vertical nor horizontal, such a vector has two components, alright? So you can express such vector, this vector or u in the vertical dimension, right? You can also express it, okay, also in the horizontal dimension. So I use u of y to represent the vertical dimension of u, or the vertical component of u, and I use ux to represent its horizontal dimension, right? Now remember, the angle is theta. So now in this particular tutorial of which of course we are going to be looking at projectile, okay, we are going to consider the velocity of a projectile in two dimensions, right? In some cases we are going to consider the velocity in a vertical dimension, and in some cases in the horizontal dimension. So now let's look at what the velocity will be when I consider it in a vertical dimension, right? So that vertical dimension is now the vertical component of the velocity. All right. So of course it's a vector quantity, right? And let's see what happens. So if I'm considering it in the vertical dimension, and that is u or y, and of course if you look at this triangle here, it's actually a right angle triangle, which of course the vertical I'm looking at is the opposite of this triangle, while the vector itself is the hypotenuse, right? And you know the ratio that represents is sine theta, of course, is opposite, which of course is the vertical dimension I'm looking for, okay, then of course divided by the hypotenuse, which is u. So if I should cross multiply, now I have that the vertical component of the projectile is u sine theta. All right, then for the horizontal, so the horizontal component of the velocity, the initial velocity u, This time around, I'm considering the adjacent, which of course is ux, and of course the hypotenuse. So I'm using cos theta, which of course cos theta is equal to adjacent, all right, ux divided by u, right? So if I cross multiply this, ux becomes u cos theta, right? So please take note of this. So invariably now, u can be expressed in form of a vector, right? In terms of ux and of course uy. It can also be expressed in terms of unit vector, right? The ux, right, is according to u cos theta. So this u cos theta, then of course the unit vector in the horizontal direction is I, right? Then of course uy, which is u sin theta, then multiplied by j, which is the unit vector in the vertical direction. So now I don't want to dive deep into vectors, right? I don't want to dive deep into vectors here. Definitely there's going to be a tutorial for that. All right, so I'm only going to be interested with some certain important parameters, all right, that we need, basic parameters that we need, okay? And that parameters is actually derived from an equation. So those parameters is gonna help us, all right, evaluate what is known as the time, okay, of the projectile to reach the maximum height, or better still, the time of flight of the projectile. Time of flight, capital letter T. That's number one parameter we want to evaluate in this tutorial. Number two parameter we want to evaluate is gonna be equal to the maximum height. Maximum height the projectile actually attains. All right. Then at the end of the day now, we actually talk about the range of the projectile. All right, R. Let's start with the very first one, which of course is the time of flight. So if someone asks you what is the time of flight of a projectile, how will you define it? All right. Now, the time of flight of a projectile, right, is actually the total time it takes the projectile to complete its journey. Total time. All right. Which simply means that analytically, I will describe the time of flight as the time it takes the projectile to first reach its maximum height. All right, because you have to reach the right maximum height before it starts falling. All right, so this time is divided into two parts. One part of the time is, first of all, the time it takes the projectile to reach its maximum height. Let me call it T1. Then he also is talking about the time it takes the projectile from its maximum height to come to the ground level. So there are two T that's involved. All right. So time of flight. Now, first of all, it's just like someone in a journey goes to and fro, okay, to a point, then return back from where it's coming from. So two of them are equal. So that means the time of flight of the projectile is the sum of T1 plus T2. And it happens that both T1 and T2 are equal. So if I get my T1, I'll just add it to I'll multiply by 2, right? But first of all, let's get the time. All right, this T1 represents the time it takes the projectile to reach what? Maximum height. And of course, you know that from here to here, all right, is the maximum height of the projectile. So we define that, we get to that point, all right? So now let's do that. Now, this time around, I would definitely need to derive the formula for my parameters, right? The time of flight, the capital letter T, I will definitely need to derive the formula. How will I derive it? So you know that we are dealing with upward, all right, motion now. So I will have to consider my U, which of course is the vertical component of, because I'm considering the time to reach the maximum height, right? So if I want to find the time to reach the maximum height, right, the U I'm going to consider is the vertical component of the U, which of course is UI. All right, UI is U sin theta. That's the first, then comma. Don't forget that I will still need to consider an acceleration to gravity, right? Let me use G to represent it. It's still what it is, all right? Then, of course, I'm looking for that time to reach the maximum height. Question mark. Then the maximum height, don't forget that the maximum height, I've told you this before, at the maximum height, the final velocity is always equal to what? 0, right? Why am I writing these parameters? Because I want to apply any of the equation under gravity so that I can use it to evaluate this T, all right? So of course, which I have U, I have G, I have T, I have V. Which equation does this capture? Of course, it captures the very first equation of motion under gravity. Okay, you should go back to it again if you have actually written the note or you've gone through the tutorial, right? So, and that equation says that V is equal to U, right? Of course, minus, because it's upward, minus GT. So in this case, V is equal to 0, right? Then the U becomes my U sin theta, vertical component of the U. All right, then of course, minus G, still remember what it is, then times the T, which of course is the T1. Now if I rearrange this equation, minus GT1 goes over to the rest and becomes GT1, right? Is equal to U sin theta. If that being the case, now remember I'm looking for time to reach maximum height, which of course is U sin theta divided by G. So that's the time to reach the maximum height. So remember the time of flight, okay, which of course is the whole idea, is for us to get the time of flight. Time of flight, which of course is capital letter T, is going to be equal to T1 plus T2, right? And two of them are equal. So you're looking at U sin theta all over G plus U sin theta all over G. So there are two of it. U sin theta all over G plus U sin theta all over G. Why? Because they are all equal. T1, T2 are equal, right? So invariably now, to capital letter T, when you add U sin theta all over G plus 2U sin theta all over G, you have 2U sin theta all over G. So please take note of this formula, all right? Very, very important. The time to reach the maximum height. All right, so I will write it down somewhere. So the very first formula we've actually derived is the time it takes the projectile to reach maximum height. The time of flight, please pardon me. The time of flight, which of course is 2u sine theta all over g. So the next parameter we're going to look at is actually the formula for the maximum height attained. Maximum height of the projectile. If I should draw that, okay, if I'm measuring the maximum height, I'm measuring it from the horizontal level, right? Vertically, not inclined. So the vertical distance, right, from the ground level to the maximum height, okay, gives you the magnitude of the maximum height attained by the projectile. So we measure it from the ground level vertically upward. That's h, the maximum height attained. So h. Now, how do we actually derive that parameter? We're still gonna consider the fact that u, all right, the u we're gonna consider is vertical component, because this maximum height now, right, which of course is u sine theta. I will also consider that g, right, acceleration due to gravity. Okay, then we also consider another thing, which of course is very important, that v at the maximum height is always equal to 0, right? Then finally now h is what we are looking for, the parameter. So now u, g, v, and h, which equation of motion under gravity does that capture? I discovered that captures the very third equation, right, which is v square equal to u square then minus 2gh. V is 0, right? U is u sine theta, so that's going to be u sine theta all square, then minus 2 times g, of course, times h. So 0 square is still 0, so minus 2gh goes over, it becomes 2gh, right? Then I have u square gives me u square, sine theta square gives me sine square theta. So with what I have now, the h is gonna be u square sine square theta divided by 2g. This is the second parameter you need to write down somewhere, that is for the maximum height of a projectile. Alright, so please take it down somewhere, it's necessary, we're going to use it. Then the last but not the least is the range of the projectile. So the question is, how can I define the range? Okay, from the graph of a projectile, you know very well that a projectile moves, then returns to the ground. So if you measure it horizontally, that's a displacement covered. Okay, so from this point where the projectile started horizontally, all right, to the point where it actually reaches the ground again, that is the range of the projectile. So in the range, we are considering the horizontal distance covered, right? So now let's derive the formula. So don't forget that the u we're going to consider this time around now is the horizontal, that is u cos theta. Now since we are not considering, all right, we are not considering upward motion, we are considering motion in horizontal dimension, then it is ideal that we said that g, all right, is equal to 0, right? Because horizontally g is negligible, right? Then of course we should also don't forget the fact that at this particular point now the motion is completed, so the time that we're going to use is going to be the time of light. The motion is completed. So now the range now becomes the question mark. Now the range now serves as a kind of distance, right, or height. So u, g, t, and of course height r. Which equation captures that? You discover that is the second equation, right? Don't forget the second equation of goes like this: h is equal to ut, then of course plus or minus, is it plus, right? Half gt square, right? So h now is the range, the u is u cos theta, the t becomes capital letter T, alright, and of course plus half times 0 times t square, right? So 0 times the whole of this is 0. So I have the range being equal to u cos theta, right, multiplied by t. Remember our t, time of flight, right? That is 2u sine theta all over g. So now I have that my range is going to be equal to, let's multiply this, okay? U multiplied by u will give me u square, right? Of course, 2 sine theta multiplied by cos theta will give me 2 sine theta cos theta. Alright, so then divided by g. Now this expression 2 sine theta cos theta, alright, is actually in trigonometry we call it double angle, alright? So probably you should go to trigonometry and actually verify or prove that, alright? So 2 sine theta cos theta is same thing as the double angle of sine theta, that is given as sine 2 theta. So the whole of this is equal to this. So my equation now changes to me having range being equal to u square then sine 2 theta, alright, divided by g. Alright, so please take note of these three formula. We're still gonna extend it, okay? But I'm interested with these three formula because I wanna solve question with them, right? Okay, I hope you're with me. So I will just write them down, okay? The first is the time of flight. Okay, capital letter T, right? Which we know that is 2u sine theta all over g. The second is maximum height, which we already know that is u square sine square theta all over 2g. Then the range, excuse me, which we know is r is equal to u square sine 2 theta all over G. Let's look at example. Let's say an object, all right, is thrown upward, all right, with an initial velocity of 20 meters per second. And we are told that this object is thrown at an angle of 30 degrees with the horizontal. Okay, and that is the information that was given, and we are being asked to evaluate. Okay, we are being asked to evaluate time to reach maximum height. Okay, then B, we will also be asked to evaluate the time of flight. C, we are asked to evaluate the maximum height. Then D, we are asked to evaluate the range. Alright, so this wouldn't be strange because the formula is handy. For the time to reach the maximum height, that is the small letter t, right? And this time around you just use sin theta all over G. So the question, our U is 20 meters per second, so that's going to be 20 sin 30 all over 10, right? So if we should do this, sin 30 is 0.5, 0.5 multiplied by 20, that's 10, right? Divided by time. So that is 1 second. So the time to reach the maximum height is 1 second. Then number 2, the time of flight, remember, is always t plus t, right? 2t, 2 times this. That's going to be 2 times 1. That's 2 seconds. Number 3, the maximum height, that's u square sin square theta divided by 2g. Okay, so what is our u? Of course, that's 20, right? So this will be 20 square sin square 30 divided by 2 times 10. So this is going to be equal to 400. Then of course sin square 30, sin 30 is 0.5, okay? So that's going to be 0.5 then square sin square 30, then all over 20. Let's get our calculator. So I will do 0.5 square multiply by 400, then divided by 20. So I have 5, of course, that's meter maximum height. The last but not the least, the range, which you already know is u square, that's sin 2 theta, then divided by g. So it's going to be equal to 20 square, then sin 2 times theta, that's sine 2 times 30 divided by 10. Alright, what do we do? That's gonna be 400. That's gonna be sine 400 sine. This is 2 times 30, right? Sine 2 times 30, that's gonna be sine 60 divided by 10. Alright, and you can go by calculator or you can go by special angle. Anyone. Sine 60 by special angle is root 3 over 2 if I'm not mistaken, right? But my calculator is 0.866 divided by 10. So we use our calculator. 400 times 0.866 then divided by 10. That's 34.64. And that is in meter. So this just gives you the basic formula, okay, that you will definitely encounter in as much as projectile is concerned. All right, because in this tutorial I want to give you the foundation, then before we now get to complex questions, right, you need to have the foundation, you need to know the origin of what will help you to solve complex questions. All right, I hope we are good to go. All right, so we're going to look at some other questions. So I'm going to bring a question up. All right, and on the screen. I hope you're with me. All right, let's flow. Sometimes you discover that the range of a projectile, the range that a projectile will eventually attain, if you ask people that throws javelin or shot put in Olympic, okay, they will tell you that it's not just about the strength or the force at which they throw the javelin or the shot put, all right. It also, the distance to which they can reach depend on the angle, right? So the range of a projectile definitely depends on the angle of projection, theta. In that we know that from the formula, okay, we know that the range is proportional to, or better still, let's go by the formula, right? The range is equal to u square sine 2 theta, right, all over g. Now there are some questions they will ask you, all right, at what angle of projection do you think you are going to have the maximum range? Maximum range. At what angle of theta do you get a maximum range? If we check it by this formula, right, the only angle of theta that will give sine theta the maximum value is 45 degrees. Why? Because when theta is 45 degrees, of course, 2 theta, 2 times 45, that's 90 degrees. And the sine has its maximum value as 90 degrees. Above 90 degrees, all right, the value start decreasing. Of course, if you draw the graph of sine of an angle, it goes this way, okay? So this is the way it goes, like a wave, right? So at this particular point where you have the maximum is 90 degrees. Beyond my 90 degrees, it start decreasing. So this is the maximum, all right? Maximum at 90 degrees. So a range of a projectile, since the projectile, all right, is sine 2 theta, so definitely this theta must be 90 degrees for me to have the range. And for this 2 theta to be 90 degrees, theta itself should be 45, so that when I multiply 45 by 2, I'll have 90. So that's one of the questions that you might also encounter. Then another question that I want us to solve goes this way. All right, I hope you're with me. All right, the question goes this way. At what angle will a ball be projected to have a range twice its its maximum height. Okay, that's a question. Then how do we tackle this question? So sometimes whenever you're being given a question, try to relate what you see in that question in terms of a formula. It's a word problems, okay? So we are looking for the angle that makes the range to be twice maximum height. So we are looking for the angle of theta that will make r to be 2h. So that expression, that sentence should be written in a formula expression, right? So what angle does make range to be 2h? And of course, you know that there's angle in range, all right? For range, we'll have u square, right? Sine 2 theta all over g, right? Equal to 2 times, of course, for maximum height, the formula is sine square u square sine square theta all over 2g, all right? So we are looking for the whole idea here is to find the angle theta that actually satisfies this particular equation. Now it is easy, but someone will ask a question. No value was given. No value was given. Yes, no value was given, but definitely from this equation, all right, values will cancel out. G is fine both sides of the equation. They will cancel. G will cancel out. Of course, these two will divide these two. All right, that's how you simplify your equation. All right, so you're left with of course, u square can also cancel u square. In as much as they are connected by multiplication, right, and they are finding both sides of the equation, they cancel out. Because if I should take any one of them, like u square to the other side, because a division, it will still cancel out. Okay, right? You should actually scale up your calculation to the extent where you could actually break down an expression into a simpler form. All right. Okay, so now I'm only left with sine 2 theta equal to sine square theta. How does this help me? It will help me. How do I actually evaluate this equation? Okay, for me to get theta, right? Don't forget where this is coming from, right? Sine 2 theta is double angle, of course, something as 2 sine theta cos theta, which of course is sine square theta. Okay, I'm gonna do one thing now. What am I gonna do? I want to make sure that I will have um, a constant value at one side of the equation, right? How do I do that? Let's say I want to have constant value, so I will divide everything. I divide through by sine square theta. Alright? So I divide it by sin square theta. Alright, so let's start that. Let's do that. So I have 2 sin theta. Two sin theta, right? Cos theta is equal to divided by sin square theta, right? And sin square theta, whatever I do to this side, I also do to the other side, right? Is divided by sin square theta, right? So you know what happens? Sin theta cancels sin theta here. So I'm just have sin theta in the denominator. So I'm left with 2 cos theta sin theta equal to, of course, 1. I will take this coefficient to the other side of the equation, right? I have cos theta all over sin theta, right? Is equal to 1 all over 2. Now, remember, sin theta all over cos theta is equal to tan theta, alright? I want to express this in terms of tan theta, so I will invert. I will invert this equation. Sin theta comes up, cos theta comes up, and once I invert it, I also invert this, right? So I will do something like this: sin theta all over cos theta. So it's going to be equal to 2 all over 1, right? And we know that sin theta all over cos theta is giving us tan theta equal to 2. So it is now easier for me to get my theta, right? Which of course is tan inverse of 2. Alright, let's flow calculator the tan inverse of 2. So shift tan. Okay, first of all, I have to put the 2. Alright, the way this calculator is the scientific calculator is being structured is such that I have to write the number I want to find the inverse first, right? So 2, then inverse 10, right? So that's 63. So that angle is approximately 63 degrees. I hope we are good. So definitely this is a good foundation, and of course we're going to look at more complex questions in the next video. I see you in the next video. Thank you.